How do we solve this nice exponential equation? We have 2 raised to power 9 raised to power x over 8 can be written as 2 raised to power 3. So we have times 3 raised to power x, which is equals to 1 over, we can write 4 as 2 squared. Recall that whenever we have a raised to power m times n, we can write it as a raised to power mn. So we are going to impose this property on this denominator. So from here, we're going to have 2 raised to power 9 raised to power x over 2. So we're going to have 3 times 3 raised to power x equals, this right hand side could be written as 2 raised to power negative 2. This implies 2 raised to power 9 raised to power x over 2. 3 times 3 raised to power x can be written as 3 raised to power x plus 1. This equals 2 raised to power negative 2. Now, recall that whenever we have a raised to power m over a raised to power n, this can be written as a raised to power m minus n. So we are going to impose these properties on this guy. So that means we're going to have 2 raised to power 9 raised to power x minus 3 raised to power x plus 1. So this equals 2 raised to power negative 2. Now, the base happens to be equal. So this implies 9 raised to power x minus 3 raised to power x plus 1 equals negative 2. We can write 9 as 3 squared. So we're going to have times x minus 3 raised to power x plus 1 equals minus 2. This implies when we switch this power, so we're going to have 3 raised to power x times 2 minus, recall that whenever we have a raised to power m plus n, this can be written as a raised to power m times a raised to power n. Using this property for this guy, we're going to have 3 raised to power x times 3 equals negative 2. Now, let y equals 3 raised to power x. So anywhere we see 3 raised to power x, we are going to replace this with y. So from here, we're going to have y squared minus 3 times y equals negative 2, which can also be written as y squared minus 3y plus 2 equals 0. If you factorize this guy very well, you are going to have y minus 2 times y minus 1 equals 0. So this implies that y minus 2 equals 0 or y minus 1 equals 0. So y equals to 2 or y equals to 1. Now, let's consider when y equals to 2. So when y equals to 2, we are going to plug it here. This implies that 2 equals 3 raised to power x. Taking the natural logarithm of both sides, we're going to have ln 2 equals ln 3 raised to power x. This implies ln 2 equals, using laws of logarithm, this guy could be written as x times ln 3. So therefore, x equals ln 2 over ln 3. This is the real solution. Now, let's consider when y equals to 1. When y equals to 1, we are going to plug it here. We're going to have 1 equals 3 raised to power x. 1 could be written as 3 raised to power 0 equals 3 raised to power x. Since the base is the same, this implies that x equals to 0, which is the integer solution.